Hello everyone, welcome to Snippet Nugget. I am Prakash and today we are going to discuss the question, a very common question. So this question is asked to generally beginner level candidates. It tests how well you are able to think about optimization and the concept of counting sort. Okay, so what is the question here? Question is very simple. If you have an array which contains either zeros, ones or twos in repeated manner, you need to sort that array. Simple, right? So your array can be something like 0, 1, 1, 0, 2, 1, 2, something like that. So basically it only contains 0, 1 and 2, no other entries. So you need to sort it. A common brute force solution which generally comes in our mind is, why not simply sort it using any of the sorting algorithm like quick sort, merge sort, or maybe big O of n square sorting it out. But that is not the correct approach. Let us discuss in detail this question. This question is generally asked to test some of the things like how well the candidate is using auxiliary space. We will discuss about it. Also, we will discuss about what is comparison and non-comparison sorting. We will discuss about the count sort because this solution is based on the sorting algorithm called count sort. Okay, we will then discuss about the counting sort, how it works and all. And at the end, we will discuss about why not we can use counting sort as one of the algorithm to sort any array. Okay, any unbounded array. Okay, so let us start from the beginning basically. What is auxiliary space? Auxiliary space means if you are given a question or any algorithm you have two types of memory requirement there. The first is the memory required for input, receiving the input, okay, storing the input data. The second type of space requirement is auxiliary space. It means the space required to store extra the processing or the temporary storage of variables and basically all the processing space which requires during the execution, that is called auxiliary space. Let me repeat in very simple language. Any extra space or temporary space requirement is auxiliary space. So the whole space complexity of an algorithm is input space taken plus auxiliary space taken by that algorithm. Okay, so in this algorithm counting sort, we are going to discuss about that we will be using one extra array, so that would be your auxiliary space. Okay, now there are two types of sorting algorithm we can categorize any. So basically all sorting algorithms can be categorized in two types of algorithms. One is comparison sort, other is non-comparison sort. Comparison sort means in order to arrange that array in sorting manner, you have to compare elements from one another. Like there would be comparison among the elements in order to find that, okay, which is smaller than the others. So let us place it in the first place in ascending order and so on. So basically comparisons among the entries or items are required. That is comparison sort. So what can be the examples for it? Merge sort, quick sort, okay, selection, insertion sort. So I think all the conventional sorting algorithms comes under the comparison sort because they involve comparing of the elements. There are non-comparison sorts, but we generally don't encounter or don't come across them. Examples for them are count sort, Radix sort, or let us say bucket sort. Okay. In this non-comparison sort, in order to arrange the entries in sorting manner, we don't compare them among themselves. Sorry, among others. So basically, for finding which is the smallest element or which will come the first, we don't compare it with other elements. We apply some other logics. Okay. So for example, in counting sort, we actually count that how many number of times this element is occurring. Okay. How many number of times next element is occurring. In that way, basically, we maintain a frequency or kind of count of each of the element and then basically arrange them. Okay. So now you can think about, okay, so this question of arranging zeros, ones, and twos can be solved using counting sort, because here basically we can count how many number of times zeros are there, then ones are there, and then twos are there. And then basically we can recreate that array or kind of erase and edit that array so that, you know, we will have all the zeros occurring at the start and then all the ones and then all the twos. Okay, so this is how counting sort works. Similarly, Radix sort also works in a similar manner, where we basically sort the first digit number, the last digit, and then second last digit. So basically we sort in digit wise manner. Then there are bucket sort. In bucket sort, basically we have buckets, or, you know, kind of the range of the numbers, and we basically put all the elements wherever they fall in that range. So basically, we, let us say, if we know that the age of the employees can be between, let us say, 20 to 60. Okay, so we know it beforehand that the entries for the age array can have only the numbers between 20 and 60. So what we can do for sorting it is we can have buckets of size, let us say 5, like 20 to 25, then 26 to 30, then 31 to 35, and so on. And we can basically place each of the entries in appropriate buckets. And then under those buckets, we can maybe apply count sort or something, okay, for counting how many number of times 21 age is occurring, 22 age is occurring, 23, and so on. So in that way, we know that, okay, how many employees are having age 20, like that. Okay, that is bucket sort. Let us quickly come back to our question. Okay, what is count sort? So as we have seen that in this, basically we count each of the entries, how many times they are occurring, and then we arrange that in the initial array so that, you know, all the smallest elements are copied first, then the second smallest, then the third smallest, and so on. Okay, we will quickly see a formal algorithm for the counting sort. So let us say if our input array is A, having, you know, n elements in it, okay, and all the elements of the input array AI is basically containing numbers from 1 to k only. Okay, there are no elements in this array which falls outside this range. Okay, now what we need is output, let us say in array B, where n elements will be there obviously, but in sorted manner. Okay, and also we will use auxiliary space or the extra or the temporary space during this algorithm or during this execution to do some, maybe, you know, processing, maybe storing something or something. Like basically all the space which are created temporarily and then used during the execution are called auxiliary space. Okay, let us see the algorithm. So for I1 to k, like, you know, for all the types of elements there can be, we will create an array C. So that will be an auxiliary array, and we will initialize all the elements to 0, the count to be as 0 initially. And then for all the elements in the array, input array A, okay, we will basically keep the count as incremented each time that element is found. So for example, if 0 is found, we will put C0 plus plus. It means we will increase the counter. If 5 is found, so we will increase the counter for 5 as plus plus, and so on. Okay, once this all is done, we will have our information in the array C that how many times which number has occurred. Please note, we know it beforehand that there are only 1 to k entries, like any elements can be between 1 to k. Okay, that is why we have our size of count array C as k length. Okay, then we will create a new array called B, and in that B we will start copying all the elements of C with its count. Simple. You can have a look over it at the end, okay, or maybe after pausing this video. Let us see about this question. Let us say our array A is this, okay, 0, 1, 2 and all. Now we will maintain our count array C. So first time we will initialize everything as 0, 0 and 0. Now we will encounter 0. So we will increase the counter as 1. Next we will encounter 1. We will increase the counter as 1. Next we will encounter 2. We will increase its counter 1. Again we encounter 2. So we will increase this as 2. Again we encountered 1. So we will increase the counter of 1 as 2. Again 0. So 2. Again 0. 3. Again 0. 4. Again 0. 5. Like that. So we have 5 zeros, 2 ones and 2 twos. Okay. Now we will create, either we can create a new array, let us say B, or we can directly, start editing here. So we will start copying 0 5 times. Then we will copy 1 2 times. Then we will copy 2 2 times. That's it. So please notice here we have not compared elements among itself, like, okay, which element is greater than which and all. We have not compared elements in order to sort it. That is why this count sort falls under the non-comparison sort. Okay. So now what would be the time complexity for this algorithm? So time complexity would be O of n. Why? Because we have traversed only once through the whole array. And again, for creating the new array, or let us say overwriting the input array. Okay. So basically we have traversed this array constant number of times. So we have traversed this array here 2 times. So 2 into O of n, or we can say O of n by ignoring the constant term 2. This is time complexity. What about space complexity? So our input array is taking big O of n, okay, because it is one complete array of size n. Similarly, let us say we have taken our array count array C. So it is taking k elements, so big O of k. If let us say in worst case we are creating a new solution array or a new array to provide the output, again it is taking n space, so big O of n. In all the cases k will be less than n, so in worst case we can take k as n, so it will be 3 O of n. So the space complexity will be again O of n, because 3 is a constant term. Okay, this is. Now a common question occurs that why we can't use the count sort for any given array or any unbounded array. Unbounded array means an array which is not having any range fixed, like the elements in that array can be anything allowed with that data type. Okay, so in that case what will happen, our count array C, where we are maintaining the count or frequency of the numbers, that will be very large, right? So for example, if our int data type can hold, let us say 10 to the power 10 as a maximum number and minus 10 to the power 10 as minimum number. Okay, so we will have to create a count kind of count array of size 2 into 10 to the power 10, right? So that any element can occur any number of times and we will maintain their count in this array. So don't you think it is a wastage of space? Because in most of the cases, lots of these spaces will be 0, 0, 0. Okay, so it will be a kind of a sparse array and not a dense array. Okay, so it is a wastage of space. There is another way of implementing it through the hash map. Like we will maintain a hash map of the numbers of elements found. But again, the situation is same. Like in hash map also, which is created internally using the hash table. In worst case, or in some cases, our hash table will grow to the size of big O of n, or the the whole range of the data type. Okay, please note here n is not the input length, n here n is the data type length. Okay, if the integer number is supporting 10 to the power 10 as maximum and minus 10 to the power 10 as minimum, then our data type range will be our space complexity. So it is a total wastage of space, and that is why we don't use count sort for basically sorting a normal conventional array and all. So I think that is all I have for this video, and thank you for being with me till now and learning about the counting sort and these concepts. If you like this video, please share it and subscribe to this channel to encourage my effort. Thank you once again. Have a nice day.